today's lesson, section 3.5, talking about complex numbers. So a complex number is when you have a real part, which is the a, and an imaginary part, which is the bi. Okay? The I is what makes it imaginary. Remember that I is equal to the square root of -1. So then when we have our polynomials, sometimes we'll have complex zeros in them as well. Now remember, we've kind of touched on this before, but remember that because in Descartes' rule of signs, there's always going to be two imaginaries in your solutions. If you have one, you have another. So that's something that you have to keep in mind when we talk about complex zeros. So for this polynomial, if I want to find all the zeros, I'm going to still choose to do the same things that I've been doing. Now I notice that the last term has an x in it, and all the terms have x, and so there's no constant here. So let's factor out the x. Okay, so then that means one of your zeros is actually 0. So now let's create our list from a rational zero theorem, and so then I get 2 and 1 over 1. So that means I'm going to have possibilities of 2 plus or minus 2 and possibilities of plus or minus 1. So let's try one of them, see if they work. Here it wouldn't help to do Descartes' rule of signs. Since there's only 4 possibilities, it would be pretty quick and painless to check for some of the solutions. Okay, so here let's say I pick 2. So then add down gets me 1, multiply gets me 2, add down gets me 0, multiply gets me 0, add down is 1, multiply is 2, add down is 0. Okay, so then here I have a solution of 2 as well as 0, and I'm left with x squared plus 1. So there, that one is going to not have real zeros because of the plus. So let's say I set this equal to 0 and solve, since it's just a binomial quadratic. So that gets me x squared is equal to -1, so that when I square root both sides, the square root of -1 first gives me a plus or minus, and the square root of -1 is I, like I said previously. So then here I have 4 solutions, like it says, but 2 of them are real, and 2 of them are imaginary, because I have a positive I and a negative I. Okay? Now, the next thing is called the fundamental theorem of algebra. It says that every polynomial, written on our general form, when n is greater than or equal to 1 and a sub n is not 0, so the leading term is not 0, with a complex coefficients has at least one complex zero. So if your if you have complex numbers in front or as coefficients for your polynomials, then you have at least one complex answer. Which means also if you have one complex, you're also going to have another one. Okay. Now that also with complex, that also goes with if you have those kind of complex numbers. They also come in the same thing as pairs. So they're not necessarily always imaginary. They might have radicals in them or something like that. Okay, so that's what they mean by complex. Conjugate zero theorem, which we kind of talked about a little bit, is if polynomial p of x has real coefficients, and if the complex number z is 0 of p of x, then its complex conjugate, so z bar, is also a 0 of p. So that's what I was talking about, where if this is a answer, then also this is an answer. So the conjugate is also true. Okay? Well, that's it. Have fun.